For CLO1, I included 6 files which tested each hardware component individually. I also included the OLED function test to debug my OLED. For CLO2, I created an object for each hardware component so that I could call the functions allowing for abstraction. I used private variables to keep my data hidden, and I also used examples here of inheritance and polymorphism. For CLO3, I used the Princeton Standard Library and Fermata 4J. For CLO4, I used Java Collections Array List for the aggregation of type data. So for CLO5, this is how the hardware interacts. So first the program gives me 10 seconds to select a threshold value. I selected 600. Since the soil is dry, the pump immediately starts. It waits for 5 seconds, and now there's a cool down. The pump now has to wait for a minute. Okay, so now the cool down is over, and you can see again the pump is ready to water, and it's watering the plant. Okay, now 5 seconds are over. It's again in cool down. Okay, so now the cool down is over again, and the pump is not watering this time. And as you can see, the OLED is showing that the moisture levels are below the threshold, and that's why the pump is off while it's ready. And if I press the button, then the program should stop. You can see the program has been manually terminated. For CLO6, I made the animation of my OLED much more smooth. Before, the issue was that I was calling the display function multiple times every second, and that was causing the LED to look completely blank. However, I figured this out and used the canvas function instead, and called the display function at the end of the loop only one time, so that it refreshed much more smoothly and made the animation much better.